Hey, welcome back. So in this video, we are going to have a look at negative exponents. In the previous video, we actually looked at what exponents are and how you can simplify them and so on. But at a quick recap, that a to the power of n, what it essentially means is that you have your a being multiplied with itself n number of times. And the a is what we call a base, and the n is somewhat what we call the power or an exponent, right? There we go. But in this video, like I said, so we are going to have a closer look at what if the n power that you have is a negative number. So for example, 2 to the power of 2, it is actually just means 2 times by 2, right? Simple enough. So that gives you a 4. But what if I was to write 2 to the power of a negative 2? What does it actually mean to the power of negative 2? What it means is that you can rewrite this as 2 to the power of 2. And then since now we are looking at a to the power to the 2 to the power of 2 just like before, then you can actually just continue writing it just like this, and then you would have 1 over 4. Now we can actually rewrite this as well, but we'll come back to that later. So every time you have a negative exponent of any power, maybe I can write it right here. So a to the power of a negative n, then you can actually rewrite it as a fraction with a positive exponent. So a to the power of negative n is equal to 1 over a to the power of n. And that is a very, very important rule that you have to remember in exponents. And this is something that you will be seeing a lot in mathematics, and especially once you get into calculus and all that other chapters. It's very important to get your head around this rule right here. So every time something is, so even if sometimes if you have something in a fraction, just like you have on the right hand side, then it's sometimes easier to rewrite this as an exponent as well. So a to the power of a negative n. Let's take a few examples. So now we looked at the power of 2, which was easy enough. Let's say if I was to write 3 to the power of a squared, that is 1 over 9. This could also have been written as 3 to the power of a negative 2. That would also have been 1 over 9. But interestingly enough, and just like I also mentioned it in my last video, that every number that you have, it is always raised to the power of a 1. So in this case, it was raised to the power of 1. This was raised to the power of 1. Any number. Like for example, if I was to write 5, 1 over 5, right? And someone asked you to rewrite this as an exponent. So why don't you just think a little on how you would actually rewrite it if you don't have, now, because in the first impression, you would see that it does not have an exponent. It doesn't have a number 2, it doesn't have a number 3, number 4, number 5. It only is 1 over 5. So this can actually be rewritten as 5 to the power of a negative 1. And this is very important, that you really have to remember that every number that you see in mathematics is actually always raised to the power of a 1. So in this case, if I was to rewrite this would be 5 to the power of a negative 1. The same goes for 1 over 2. That would then just be negative 1. For example, now you can rewrite this as well by saying this is actually 4 to the power of a negative 1. Now, just like now in this method, like I've shown you, we have gone through a very complex way of rewriting this in a fraction and then going on and then simplifying it and then rewriting it as to the power of a negative 1. Let's take a simpler example just so that you can get your head around on how is it that it actually matters. That what you can do is, let's take 2 to the power of a negative 2, right? And let's rewrite this exponent in a different manner. Let's say if I was to rewrite this as 2 to the power of 2, and then we write a bigger bracket and we raise this number to the power of a -1. Now, once you have an exponent right here and you have an exponent on the brackets, you can actually multiply both of them together. So you end up getting -1 times by 2, then that is a -2. So in this case, you would get a 4 because 2 raised to the power of 2, that's a 4. But now since you have a brackets and on the bracket you have a -4, so you end up getting 4 to the power of a -1. Because remember, like I said, this is a 1 right here. So 1 times by -1, that is a -1. So that is another way on how you can simplify an exponent, or not simplify it, but how you can solve it without having to rewrite it in terms of fractions every single time. But this is essentially what is happening behind the entire process. So if something is raised to the power of a -2, then what it means is that you need to rewrite it as 1 over 2 to the power of 2, and then since of course that is just simply 2 times 2, that's 4, then you get 1 over 4, and then you get a 4 to the power of -1. If this is the first time you are seeing or you're solving exponentials, then I would strongly suggest that you actually use this method, because that's just the best way to get the better understanding of how things are being solved, and you would have a much lower chance of making a mistake. But of course, once you start to get your head around it, then it's always a good idea to start solving them in this way as well, because that's essentially how you will be solving it. Because when you're dealing with more complex equations or functions, then it's always a better idea to always play around with the exponentials instead. Another example that we'll look at is, for example, that we had 1 over 5 to the power of a -1. So now it is a fraction. So we have 1 over 5 to the power of a -1. How would you solve that? So what that means is, let's take it the very simple way of what it actually means. Then this is 1 over 5, correct? Now, if you're not aware, when you are dividing, when you have fractions within a fraction, there is a rule that states that you can multiply the numerator with the reciprocal of the denominator. So what is the reciprocal of the denominator? The reciprocal means that, for example, if you have a to the power of divided by b, then the reciprocal, okay, it's not an equal sign. Reciprocal is b over a. So that means you invert the numerator with the denominator and the denominator with the numerator. So you kind of like turn the fractions around. So if you were to like to simplify this, that means that we would like to multiply it with what? 5 over 1. Yep. So that, and then you actually end up getting just a 5 as the final answer. So that's essentially is what you how you would simplify an expression that looks something like this instead. The reciprocal of this being multiplied with the numerator, and then you, of course, that is your final the answer. Now I actually wrote it wrong, because let me rewrite this so that it's less confusing. So 1 over 5 to the power of -1, that was 1 over 5. Then actually it's 1 times by 5 divided by 1. Yeah, sorry, I forgot to add in an extra step. And then you actually end up getting a 5 towards the end. So that's essentially so that's how you would normally solve if you have a fraction within a fraction, and that's very common. Let's take a bit more of a let's take a more how to say it, a more complex fraction. Let's say if I was to write 3 to the power of a -2 divided by 2 to the power of a negative, let's call it a 1, just to keep it simple. So what this one mean, what the above expression means is 1 over 3 to the power of a negative 2 divided by 1 over 2. Now using the same, oh sorry, this was supposed to be a plus 2 now because it's a fraction, right? Now using the exact same method as before, just like I said, when you have a fraction within a fraction, then you need to multiply the reciprocal of the denominator with the numerator. So that means that it will be 1 over 3 squared multiplied by 2 divided by 1. Now we know that 2 times 1 is 2, and then 3 squared times 1 is 3 squared. And then let's simplify. 3 times 3 is 9, so you end up getting that fraction. Right? Let's take another example. Let's say let's say 2. Someone writes an expression that looks something like this, times by 3 to the power of a negative 2. And now you have been asked to simplify that expression. Now, a piece of advice: when you are dealing with exponents, with negatives and the positive numbers, don't try to solve them right away, because that's how you actually end up making mistakes. The best way to do it is to write them up in a simple, orderly fashion. So we'll rewrite this as 2 squared divided by 3 squared, because now it was a negative, right? So we need to take it down to the denominator, and then you can simplify it. So now it's 4 divided by 9. So always keep that in mind, that every time you have a negative exponent, it just essentially means that you have to rewrite this as 1 over that number, or with that exponent. And every time you change, you can also rewrite fractions just like we did earlier. Like for example, if someone asked you to rewrite this into normal in one line, then you could just rewrite it as to the power of a negative 1. This is actually something very common. You normally don't see that much in mathematics, but in physics, just to give you a quick example, like for example, you may have noticed that many times they use the term kilometers per hour. So in reality, you may have seen in some papers or in some textbooks, they also rewrite it as kilometers times by hours to the power of a negative 1. What it actually means is that it's just kilometers divided by hour, but instead of having to write the fraction every time, you can just rewrite that in one line. So that essentially is the entire definition. So going back, if any number is raised to a negative exponent, all you need to do is rewrite that as 1 over a to the power of n. And that is exactly what having a negative exponent mean in terms of mathematics. So, well, thank you so much for watching, and I hope the video was helpful. And if you have not done so already, then do remember to subscribe to our channel for more videos. Thank you.